Hi students, welcome to lesson 5, chapter 11, three-dimensional geometry. In the last 4 lessons, we have been studying straight lines in space. We have seen the equation of straight line, then the angle between two straight lines. So these are the concepts we studied. In this present lesson, we are going to learn about skew lines. So skew lines are special type of lines in space. First, so look at the two separate conditions. One is nature of line in the plane. Plane means 2 dimension, and space. Space means 3 dimension. See, there are two different possibilities. Line in a plane. That means if you take any two lines in a plane, so there are two possibilities. Look at the first possibility. So the lines can be intersecting like this. First thing is both lines are on the same plane, coplanar, so they intersect. This is one possibility. So let me say intersecting lines. Second one is they may not intersect, so definitely they should be parallel. So parallel lines. Therefore, whenever two lines are belonging to the same plane, that is coplanar, then there are only two possibilities. One is intersecting, another one is parallel. But this is not the case with the space lines. For example, consider the lines in space. Actually, there are three possibilities. First one, look here, there are two lines which are intersecting. But intersecting lines will belong to one common plane. So once again, they are coplanar. So this is one possibility. Second one is the two lines may be parallel like this. In this case, they are also once again coplanar because you can find at least one plane passing through both of them. Therefore, that is parallel line. But there is another special case that is very interesting. That is, there are two lines, they are not intersecting, they are not parallel also. And this is not possible in case of two dimension. So in space it is possible. Look here, there is a box. Imagine there is a line like this on the top of the box, that is on the top plane. So there is a line. Now similarly you can imagine another line which is on the bottom plane. Now it is very clear they are not parallel. Second, they cannot intersect also. So this type of lines are called skew lines. Here there is one special feature which you can study. Look at the skew lines given in the diagram. Now you can select one point on the top line, another point on the bottom line, such that the distance between them is shortest. And if you take any 2 points, any other point, it will be more. So you can have variable distance, but there is one pair of points on both lines which gives you the shortest distance. So we are going to find the formula for shortest distance. Let us proceed. So this is neither intersecting nor parallel lines, that is called skew lines. So shortest distance between two skew lines, we can take it as a theorem. If L1 is R equal to A1 plus lambda B1 and L2 is R equal to A2 plus mu B2, P skew lines, then the shortest distance between them is given by this formula, D equal to mod of B1 cross B2 dot A2 minus A1 divided by B1 cross B2 magnitude. So whenever I say A1, B1, etc., it is vector. So let us prove this one. We have L1, that is R equal to A1 plus lambda B1, and L2, that is R equal to A2 plus mu B2. So these are the two skew lines. So L1 and L2 are skew lines. That means what? They are neither intersecting nor parallel. They are space lines. Now let us have a diagram. L1 is like this and L2 is like this. Please note, this is in space, not on plane. Now let S be the point on L1 with position vector A1, because equation of L1 is R equal to A1 plus lambda B1. So A1 is a point on the line. Therefore let me call it as S, and its position vector is A1. Similarly, T be the point on L2 with the position vector A2. So it is shown here like this. T is A2. So these are the things. Let us join them. So this is the distance ST. Now let PQ be the shortest distance between the lines. So in the diagram, P is the point on L1, Q is the point on L2, and that is the shortest distance. Students, please note in the diagram, it appears PQ is more than ST, but it is in 3 dimension. You have to understand. Therefore, I cannot give you the exact diagram. You have to visualize it 3 dimension. So PQ is the shortest distance. So that is the thing. So PQ be the shortest distance between the lines. Then PQ is perpendicular to both the lines. See, that is one condition. Whenever you want to find the shortest distance, that distance, when you join the point P and Q, that QP will be perpendicular to L1 also, and it will be perpendicular to L2 also. That is the condition. Now, PQ, let us take it as D. So this point is D. So now, since PQ is perpendicular to both lines, so PQ is perpendicular to B1 and PQ is perpendicular to B2, because you see here PQ is a line segment perpendicular to L1, but L1 is parallel to B1. Therefore, PQ must be perpendicular to B1. Similarly, PQ must be perpendicular to B2. Therefore, from the concept of vectors, PQ vector, if you take PQ as a vector, that will be parallel to B1 cross B2. B1 cross B2. So let n equal, that is unit norm vector n equal to B1 cross B2 divided by magnitude of B1 cross. That is unit vector in the direction of B1 cross B2. That means it is also in the direction of PQ. Therefore, we can say PQ vector will be equal to D times N. What is D here? D is the length of PQ. Therefore, this concept you have studied in vector. Whenever PQ is parallel to unit vector N, then PQ vector will be equal to its magnitude, which is D, into the unit vector N. So this is the understanding. Let us proceed. Now, suppose theta is the angle between ST and PQ. ST and PQ. So they are not parallel. So they are inclined lines, actually line segments. Let us say theta is the angle between them. Then D will be equal to PQ. That will be equal to ST cos theta. So this is a very simple thing. You have already studied projection of one line on another line. Using that concept, we can say D will be equal to PQ, but PQ will be equal to ST mod cos theta. Mod cos theta. So this is the formula even actually have studied in vector. Now let us take it as 1. Now cos theta equal to, see, cos theta is the angle between ST and PQ. Therefore, you can say it is PQ dot ST divided by magnitude PQ into magnitude ST. This also you have studied in vector. Cos theta will be equal to A between any two vector is A dot B by magnitude A, magnitude B. Similarly here, cos theta is the angle between ST and PQ. Therefore, cos theta will be equal to PQ vector dot ST vector divided by magnitude of those two vectors. Now, what is vector PQ? Vector PQ will be equal to D into unit vector N. We have already seen. Now, this is already given. What is ST? This also you can find. What is the position vector of S? It is A1. What is the position vector of T? It is A2. Therefore, by definition, so vector ST will be equal to difference of the position vector, that is A2 vector minus A1 vector. Therefore, so this is I have just shown you by encircling the vector. Now, therefore, this will be equal to substitute. So, PQ is D times N vector dot ST is A2 minus A1 divided by what is magnitude PQ? It is DST. So, now magnitude PQ is D, magnitude ST is ST. Now, we can cancel D and D. So that what we are getting is we get n dot a2 minus a1 by st. Therefore, cos theta will be equal to n dot a2 minus a1 divided by st. Now, what we do is cross multiply st. Therefore, you get st cos theta will be equal to n dot a2 minus a1. St cos theta will be equal to, that is taking st which is on the right hand side to the left hand side. Now what we do is take mod on both sides because we don't want a negative sign. Therefore what we do is, because cos theta can be negative also, so st into mod cos theta will be equal to mod of n dot a2 minus a1. Now look here, from 1, what is st cos theta? It is d. That's what we are interested. So d will be equal to, now because st cos theta is d, that will be equal to n dot a2 minus a1. Actually this is the formula. But now what is n? Just recollect, n is b1 cross b2 divided by magnitude of b1 cross b2. So therefore we shall substitute this here. So this is the final formula. Therefore distance d, that is shortest distance, is equal to mod of b1 cross b2 dot a2 minus a1 divided by magnitude of b1 cross b2. This is the formula for shortest distance between two skew lines. So please remember the formula also, because sometimes you have to find the shortest distance using this formula directly. So this is the proof. I know this proof requires lot of rethinking, and probably you have to watch this portion at least 2-3 times till you get the idea very clear. Let us proceed. Cartesian form. So once you, this is the tradition in 3D geometry. Once vector form is derived, then parallelly we have to find the Cartesian form also. What is given here is L1 is x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1. This is Cartesian form of the line. And second one is x minus x2 by a2 equal to y minus y2 by b2. This equal to z minus z2 by c2. Then the distance d will be equal to this one. You have to remember. So first one is x2 minus x1, y2 minus y1, z2 minus z1. That is a determinant. a1, b1, c1, a2, b2, c2. This will give you actually a2 minus a1 dot b1 cross b2. Then below what you have to do is magnitude. Therefore it is b1 c2 minus b2 c1 square plus c1 a2 minus c2 a1 square plus a1 b2 minus a2 b1 square. It is very easy to remember. See here what you have to do in the denominator, bc, then ca, then ab. That means it is cyclic. bc, ca, ab, then 1 2 2 1, 1 2 2 1, 1 2 2 1, and square. So this you have to remember. So this is the formula. If the Cartesian form is given, better you use this formula. If vector form is given, you can use the previous formula. So that is the difference. Now let us proceed. So example we shall take. Find the shortest distance between the lines L1 and L2 whose vector equations are, first one, a vector r equal to I plus j plus lambda times 2i minus j plus k, and r equal to, second line, 2i plus j minus k plus mu times 3i minus 5j plus 2k. So let us solve this one. What is a1 here? a1 is here I plus j, the first line. Then what is a2? a2 is 2i plus j minus k, that is second line. Then what is b1? b1 vector is 2i minus j plus k, and b2 vector is 3i minus 5j plus 2k. These are the 4 informations we need. That's all. Now first what you have to do, write the formula. What is the formula? Shortest distance d equal to b1 cross b2 dot a2 minus a1 divided by magnitude of b1 cross b2. Therefore first what you have to do is b1 cross b2 we have to find. So what is the method? Determinant method, ijk. Then component of b1 you have to write. Component of b1 is 2 minus 1 1. component of B2 is 3 minus 5, 2. Now simplify this one. You know how to expand the determinant. So I into minus 2 plus 5 minus j into 4 minus 3 and plus k into minus 10 plus 3. After simplification you get 3i minus j minus 7k. So this is B1 cross B2. Now therefore we need magnitude also. Therefore B1 cross B2 magnitude will be 3 square 9 minus 1 square 1 and 7 square 49. Therefore simplify, you get square root of 59. Now one more thing you have to calculate. B1 cross B2 dot A2 minus A1, that is dot product you have to calculate. So substitute B1 cross B2 we have already determined, that is 3i minus j minus 7k, and then A2 minus A1 is, see, A2 is 2i plus j minus k minus A1 is I plus j. Therefore simplify this. So you get 3i minus j minus 7k dot I minus k. This you have to simplify, you get 10. Now apply this, substitute these values in the given formula. So D will be equal to mod of B1 cross B2 dot A2 minus A1 divided by mod magnitude of B1 cross B2. So that will be equal to root 59 divided by 10. So this is the shortest distance between the two skew lines. So once you know the formula, there is no difficulty. Only thing is, first you find, this is the procedure you have to follow. B1 cross B2 you find first. Then also immediately find magnitude. Then you take the dot product B1 cross B2 dot A2 minus A1. Then substitute in the formula. So thank you for watching this video. Hope you have followed the concept which is required for deriving the formula, especially skew line. Finding the shortest distance is not very simple because the procedure is very lengthy. Cross product you have to find, then magnitude, then dot product. So please subscribe if you have not yet subscribed, and share with your friends. Watch all the lessons from the lesson 1 till this one. I will be continuing this, of course some more examples on skew line we have to do. That will be the end of the lines. Then of course we have to go for planes. Let us meet in the next lesson. Till then, bye, take care.